All right, that should have closed up about a minute ago. So let's have a look at the solution to diffuse the bomb. And welcome back today. Okay, so this semi-stressful experience of having to diffuse a bomb within 10 minutes. Let's see how you were supposed to do it. So there was a lot of code to read in a very short amount of time. The goal here was to figure out what you needed to know and then ignore the rest as quickly as possible. So you need to get into the habit of reading code quickly because, as with all writing professions, reading is the majority of what you do. Writing is the minority of what you do. So let's look at what you were supposed to read. So the first line in the driver where you were supposed to add your code was read instruction manual. So you probably want to go look at that. It says it prints the bomb's instruction manual to the console you had access to the bomb class. You should go over there and look and see what would have printed. Now, you obviously couldn't retype all this, and there wasn't any way to get it into your editor quickly enough within 10 minutes. So it says, to diffuse, cut all the wires containing the color red first, then cut the blue wire. After those wires are cut, attempt to push the button. So we're going to need to do some cutting and some pushing. Let's read through the methods and see what we have. We have cut wire and push button. So that's pretty obvious. And then we have yeet bomb. Okay, I guess that's happening anyway, since I put that on the end of the driver there and said you needed to fill in the code. Okay, so there was yeet bomb. And then there's check boom, which is private, so we don't have access to that. And it looks pretty confusing, so maybe we shouldn't touch it. And then we've got boom, which is obviously our failure condition. Boom, you died. Alright, so if we need to cut some wires, we should probably go look into how wire works before we try doing that. So let's look at the wire class and see it's got two fields. It's got the string type, which is public, and then a boolean of whether it's cut or not, which is obviously false when it starts. So we just set that to false in the field there. You can cut the wire with a method called cutWire, and it just sets this cut to true, and then you can get whether or not a wire is cut with check is cut. So pretty straightforward. We have type, and then we can figure out if a wire is cut or not, and we can set it to cut, but we can't uncut a wire. So obviously you can't. Well, I mean, you could splice them back together, but that's not cutting. That's something else. That's splicing. And we don't have that feature here. We don't bring splicers to bomb defusal camp. Okay, so what kind of wires do we have to work with in the bomb? Remember, we're looking for red and blue ones. So the wire array that this bomb has 5 wires. It's got red striped, blue solid, pink striped, orange and red, and ground. And we have these constants at the top. So what are these for? Well, when you have an array of stuff and you don't want to have to remember which index is which, it's common to do something like this. You make a bunch of final ints at the top, and these guys refer to your array indices. So the final keyword here, if you don't remember, from 128 indicates that a variable can no longer be changed. So it's not mutable. We can't add 1 to it or multiply it or anything. It's 0 for the duration of this program. Blue solid will be 1 for the duration of this program. You can't change them once you've declared them up here. So that's what that final keyword means, if you forgot. All right, so we have these 5 integer finals, and those correspond to the indexes of the wires that were declared up here. So red striped is 0, blue solid's 1, pink striped is 2. So that gives us a quick way to access the wires by their roughly by their name, rather than having to remember which index is which. And then we have the goal here, which is to diffuse the bomb. That is diffused Boolean, and that's going to get checked when you try to push the button. It's going to say is diffused is true, and then it's going to say bomb diffused, which is the text that we're going for the win condition. We need to see bomb diffused in order to get our 100% on this quiz and not explode. So we're going for that. This actually never ends up doing anything because we just set it to true and then it's never used again. So it doesn't particularly matter. It's more of a distractor. Okay, when the constructor for bomb, which we've invoked, it's blank. It creates a new bomb with those wires that we just described. And now our goal is to cut those wires. So let's look at how cut works first. What do we need to give to cut in order to successfully snip those wires? So cut loops through the array of wires, and then it checks if the wire's type contains the string description that you pass to it. And then if you read the document for it, it says cuts all wires containing the given text in their type. So then that's pretty straightforward. What do we need to do in order to cut all the red wires? Well, according to this, we just need to pass it the word red. What do we do to cut all the blue wires? We just pass it the word blue. So that's the first step there. It's going to be our bomb, and then we're going to, helps if you spell it right, we're going to cut the wires matching the description red. If you did it twice, that's fine. I'll probably give you a full credit for that. If instead you try to actually use the description of the wire, so if you said the whole thing, if you said I'm going to cut the wire called red striped, that's going to be fine too. You would have then had to cut the one called orange and red too. So that would also be fine. But all you needed was the cut red, because the description says that it cuts all the wires containing the given text, so it would cut all the red ones. And we got the blue one, of course. We got the blue one. I made everything lowercase. If you messed up your case sensitivity or you made a typo in the string, I'm not going to knock you for that, so I'll just assume you spelled it correctly. Generally, when you're comparing strings like this, you should convert them all to lowercase before the comparison, because you're only interested in the contents and not in case sensitivity. But I thought that'd be confusing here, since this is already a pretty long statement. So we're accessing a wire in the array, we're accessing its type, we're using that contains method, which you might not have seen before. It's a method of the string wrapper. So if you hadn't seen it before, you could have tried it out real quick in your development environment, or just guessed, and you probably would have guessed correctly. Returns true if and only if the string contains the specified sequence of character values. And then after the cut wire method executes, it checks boom. If you had cut the wires in the wrong order, you would have a boom at this point. So if you cut blue before red, it would give you a boom. But there's one more thing we forgot to do. We forgot to push the button, which is what it tells us. After the wires are cut, attempt to push the button. So let's just push the button and see what happens. It's going to be the bomb dot push the button. And if we run this, we should see bomb diffused. Bomb diffused. We win! Hooray! Alright, let's try doing some things out of order. Let's try cutting the blue wire first. Cut the blue wire first. Boom, you died. It still says bomb diffused at the end, because I was too lazy to actually do anything with that variable, and I didn't want to make it more complicated by putting if checks in front of everything. But the quiz said if you get boom, you died. It doesn't matter what you get, you lose anyway. Alright, so any questions about the bomb? That's it. Cut red, cut blue, push the button. Good exercise in simplifying everything. Realistically, the only code you needed to read here was the print line statement inside read instruction manual. For everything else, you could have just taken the documentation's word for it, and you would have been correct here. So if you had just read the instruction manual and then the description of the wires at the top, their textual description, that probably would have been enough. Alright, that's the bomb. I'll upload this to Canvas too for your use. Might come in handy on that first homework. There's definitely some object usage here, so could be useful. Alright, so today we're going to get into looking at some real-life kind of classes, objects that mimic real-life things. I don't really like to do this because it sends the wrong impression. It sends the impression that we group things into objects to simulate real life. That's not why we group things into objects. The reasons why we group things into objects are numerous. We group them in objects to avoid code repetition, to make it easier to understand. But the main reason that we group things into objects, the main reason that this kind of programming exists, is for us to better be able to understand the state of the program. We break the program state up into these little chunks called objects. Every object has its own fields, right? It has its own methods. Those are part of that object state. Now, when we break our objects up into these, or when we break our program up into these little objects, it's much easier for us humans to grasp at least some part of the program, whereas when you don't have objects, you have to grasp the entire program state to really understand it. Objects let us narrow that down significantly. So the whole point of object-oriented programming, remember, is to simplify state. We think of object-oriented programming as a bunch of objects sending messages to one another, exchanging information about their state, modifying each other's state. That's the only reason we do it. All right, so anyway, don't get distracted with the real-world things, but these can definitely help making it understandable. I'm going to make a new package called, let's call this pets. Pets. And I'm going to make a driver for it, as always. And I'm going to check the box for the main method so I don't have to type it in shame. And then I'm going to make a new class called pets. Class called pets. All right, so in either chat, what kind of pets do we want to support? So I'm going to have a string type here. I'll make this private. And add our getter right away. What kind of pets do we want to support in this program? We're going to have pet penguins. So when you have a variable like this, where you have specific types in mind, you're definitely going to want to document it with a Java doc document, so you have something on hover over. And you're going to want to list possible types. So penguin is a possible type here. And now when somebody wants to know, well, what are my possibilities, they can hover over and see. Returns the pet type, and then we also want to be able to see what are the available types here, and we can accomplish that by just linking this to the other variable. Okay, all right, you know what? That's fine by me. Let's see, does that work? Yes. Okay, so now we can see the possible types by just following that. So it's going to be penguins, cats, and monkeys. Monkey. And pets have other properties. Let's say that they have a name. Now the name can obviously be public, right? Because anybody can change the name whenever they want. That's the normal conception of a name anyway. And so let's build our constructor for this. We take a type, and we take a name. Okay, and now we want our pets to be able to do something, so let's have them be able to do a trick. I'll just have that be a void, so let's say do a trick. Forgot my void. And I want my pet to be able to do a trick depending on what kind of pet it is. So if type dot equals content equals should work, but let's go with regular equals to not be confusing. Type dot equals penguin. In either chat, what trick do penguins do again? While I finish typing out this statement. Penguin does sick belly flop. Cat. Let's go with knock something over. It's a very cat thing to do. And monkey. Let's say monkey invent society. That's monkey's trick. So we got our cat, our penguin, and our monkey. And they do different things, and we call this do trick method. So prints a message to the console depending on the animal's type. That can be a useful description here. We could specify the types again here, or provide a link to the available possibilities here. So we could say something like supported types, and then again link to the other thing so that it's easier to see the different possibilities that are available to us. Okay, so in the driver, let's make one of these 3 pets. Alright, let's make these 3 pets in driver. So, El Penguino is going to be a new pet. He's going to be of type penguin. That's the first field there is the type, I think. And we're going to call him Mr. Waddles. So he has a conventional name and a variable name, something that you don't want to get confused. So type and name. Oh, I should have documented this constructor too. Creates a pet with the designated type and name. Pets with designated type and name. If you do want to follow along with me, you don't have to put the comments. You can always have mine after I upload it. So it gives you some time to catch up with me while I'm writing the comments. But again, I don't really encourage you to follow along. It's probably just going to make you focus on nothing but typing. Alright, so in either chat, if we wanted El Penguino to do a trick, what would that line look like? How do we call do a trick on him? Whilst I write these other 2, how would we call on him to do a trick? We've already forgotten what pets we have. Elgato. How do we call on our penguin to do a trick? Just call him Mr. Pibb. El Penguino.do a trick, that's right, so we're going to do El Penguino.do a trick. Now when you have complicated variable names like this and you don't remember how to spell them, remember that one shortcut in classes is to use this, but we don't have that option in the main method because it's static, so we can do control space, which provides us the fields that way. So remember that's how we access that sysout too. Control space is the general command for accessing the helper or tooltip drop-down thingy out of nowhere. So if we do control space in the void on main, we can get the fields quickly that way. So if you're a slower typist, or if you have trouble remembering variable names like I do, that's a great trick. Control space in the void to get the variable name. You'll see me do that sometimes, so I don't want to seem like that's magic. Alright, so Penguin does a trick. Let's run this and see if it does what we expect it to do. Penguin does a sick belly flop. And we'll do the same thing for the cat and the monkey and see if we get the same thing there too. We got cats and we got monkeys, so we should see 3 tricks all together here. Knock something over and invent society. Alright, so how do we also print out, let's say, the pet's name before we print out the trick? So what if we wanted to print out the pet's name too? Well, that'd be pretty straightforward, right? We have the pet's name accessible through, let's say I want to print out the cat's name. We have the pet's name accessible through a field, so we could just print its name out like that. If we wanted to change the pet's name, it's also accessible to us because that field is public. So if we wanted to change the pet's name, we could easily change it to something else. Changing it to Kitty. And now when we print it out, forgot the important part. Now when we print it out, it should show Kitty instead. So we change the name there. We can't change the type once we've created the animal. We can change the name. Alright, this is cool, but there is a little bit of disorganization here. First, there's these different types that you have to review through the comments, right? And that's a little bit annoying that you have to look at the types through the comments instead of just knowing a possibility. So today's kind of point in doing this is to look at what if you want a variable that has a finite number of options, like our type does here, where we got 3 options, penguin, cat, and monkey. What if you want a variable like that, and you want it to be obvious what the options are, rather than having to specify them either in the comments, or we could also do something like public final string penguin type. We could also designate something like this so that programmers in the future can see that that's one of the options that we look over here. And then rather than doing this comparison like that, we could do something like this. That would be a little bit more understandable too, a little less room for error. So that's not bad, but we can do even better. There is a kind of variable that you can make when you have a finite number of options, when you want a finite number of options. And that variable is called an enumeration, or an enum. So for now, you can think of an enumeration or an enum as a variable that is a finite list of options. Later on, we'll see that you can actually add values to enums, that they're actually full-fledged classes themselves. But for now, let's just look at how an enum declaration works. So if you make it public, then you make this kind of variable accessible from other classes. The most frustrating part about enums is that they're bound to the class you make them on, and so they require you to call pet.whatever to invoke them in this case. So we'll see how that can be irritating and how we can get around that. So we've got our pet type. Oops, no brackets, sorry. So our enum pet type, you see enums get their own color in the little color scheme of the editor. In this case, they're pink. And all you have to do is specify the different options that you want this variable to be. So in this case, it's penguin, cat, and monkey are the 3 options. And you'll notice I have capitalized the name of the enum. That is the convention here. So you start with a capital, and then you do normal camel case. So unlike variable names, which start with the lowercase, enums typically start with an uppercase. You'll see Java enforce this rule whenever enums come up in the system libraries too. And then all the different options are conventionally all caps. So all caps penguin, all caps cat, all caps monkey. This designates that variable type. Now if we want to use it, I'm going to get rid of that comment here because it's about to be obsolete. Rather than making our type a string, we can make our type a pet type. So we're using that enum as our type instead. And of course, rather than taking a string as an argument, now we have to take a pet type as an argument. And I'm going to comment this out for a second, and then we'll see how to do it with the enum. And then rather than returning a string here, we're going to return a pet type. So I had to make a few changes to convert that. So I converted all the instances of string to pet type. Okay, first let me save this and then fix the defect that appears in driver, because obviously we don't take a string as our argument anymore. Then we'll go back and finish the do trick method with the enum, because we'll see that there's a little easier trick for it now. Let me know if you have any questions up to this point on the enum so far. So the declaration of it here enumerates the name of it, and then the options that it's going to have. You can put as many as you'd like, so we can put more options here too. You'll notice that there is no default option. So like strings, for example, if you don't set a type, if type wasn't designated here, it would default to null, like any other object would. So it's like an object in terms of how it's used as a variable. Okay. Onto the driver in order to fix these. So rather than passing penguin in parentheses and cat in parentheses and whatever the infinitely different types that there are in the world, we pass the enum's name, which is going to be pet.petType dot, and then in this case it shows you the 3 options, so we're going to go with penguin. So see, the irritating part was that I had to type pet each time. I can't just say petType dot cat, or can I? What happens when I do that? When I do petType.cat, what it does is it adds an import statement to the top of my class, and it imports the enum over from here the pet class into whatever class I'm working on it in, and then I can actually use it without having to call that extra pet line. Generally, I'm going to use the version that uses the long kind, because I don't like having to mess with those imports. But what happens is it ends up importing your package name as well, and that gets confusing very quickly, and you can't get rid of the package name, unfortunately. It'll go back and fix it for you. So if you want to use this version, if you don't want to have to type pet before every time you use the enum, you need to import it from the pets class. Everything else is the same so far. It hasn't changed anything. Now let's go back and fix that do trick method using the enum. Let's look at the fancy trick that Java makes available for us. I'm going to take a poll first. Is anybody familiar with the switch statement? Did you guys use the switch statement before? Have you used switch statements prime? I was pretty confident that you didn't do enums in 128. We normally don't do that, so I didn't even ask for that one. But have we used switch statements before? Okay, so overwhelmingly no. Gotcha. All right, a switch statement is nothing but an if statement. It's just a fancy if statement. When we have if statements like this, they are ugly and they are long, and they are just checking the same thing every time. It's just type.equals, type.equals, type.equals. We don't like seeing if statements with bunches of else's like this, just because they're ugly. So when you have one variable that you want to check against a bunch of different possibilities, the shorthand for it is a switch statement. So in the switch statement, you put the variable that you want. I'm going to do a simple example then, since we haven't seen it yet. Let's go with x equals 5, and then I'm going to do a switch statement on x. So I've done x equals 5 and a switch statement on x. And then I can list all the possibilities that I think that x is going to have. So let's say x could be 1. That's going to be case 1. You'll see this really weird syntax. It's the word case, the value that you expect it to be, and then a colon, which we never use elsewhere. And I'm not sure why that when they wrote the switch statement, they decided they were going to use colons in the syntax. That's a shame, but is what it is. Okay, so does something on 0. Make this a little more interesting. We'll do math.random times 5. Cast that to integer. Okay, so it does something on 0, and then you might be tempted to just do this. So say case 2, and then say it does something on 2. I don't know why I said 0. That's a 1. So it does something on 1, does something on 2, but we're actually missing an extra important keyword here, and this is something that people who don't use switches always forget. At the end of every case, you also need to put this word break. So after you're done writing the stuff that happens at the end of every case, you also need to add that word break. Break, and so forth. And then so forth for all the other different cases. And then you might say, well, what about the else branch at the end of a series of if statements? What about that one that executes if it's none of the cases? Well, for that one, the switch statement has another special keyword, and that's going to be default. So this is going to be what happens if none of the cases are true. And here we need a break at the end too. And that concludes the switch statement for x here. So this is equivalent to if x equals 1, else if x equals 2, and then else. These two are equivalent. And you might argue that this one is easier to read right now, but wait till you have 5, 10, 20 else branches going on. But that's not the best thing about switch statements. I'm going to delete this if there are no questions. So I'm just going to wait a minute for questions and then delete this and do one for the enum instead. But the best thing about switch statements is how easy they are to generate. These branches you saw when I was typing down here were hard to copy, right? I had to like kind of trim this and add it. It's always a pain to copy else branches like that. These are really easy to copy. You just copy a case, paste it, and change the number. Somebody asked, what happens if you forget to omit the break? If you forget to omit the break. Let's look at what happens when you forget to omit the break. I'm going to set x to 1 to rig it, and then let's see what happens when I forget to omit the break. You'll see that every time it executes, it does the something on 1 and then does something on 2. If you omit the break, it moves on to the next case and executes that case too. It just doesn't bother to do the check. So here I'll try getting rid of that break too. Now it's executing all 3 of the statements every time it happens. It's just moving on. So if you omit the break, it's going to execute multiple lines instead of just the ones that you're looking for. So it's similar to ending the loops and such. Yes, as someone said in Discord, it's similar to ending while loops and for loops. Break gets you out of the loop. Here, break gets you out of the switch statement. If you don't escape the switch statement after your case executes, you'll just stay in it, and you'll end up executing all the different cases that you didn't mean to execute. So basically, as soon as it detects a successful case, it begins to read the statements, and it doesn't stop until it hits a break. Alright, so to the convenience that has to do with enums. Alright, so instead of having to write out all these if statements, when we have an enum, Eclipse is smart enough to know that. And so remember, our enum's name is type here. If we just say switch type like this, it's going to offer us to add missing case statements in the autocorrect here. Add missing case statements. And then, boom, we have the whole if statement generated just like that. So we can add our penguin case, and we can add our cat case, and then we can add our monkey case, and we're done in just mere moments. So I find this to be a very, very helpful feature. My personal preference is to indent the cases. The auto formatter doesn't like that, and it'll keep putting it back on me. I might change it in my settings because I prefer it indented like if statements are. But up to you, of course. Right, so that was really quick. One more time, just to demonstrate what I did. So I just typed switch and the name of my enum, and then I hovered over and used the add missing case statements suggestion, and that added all of them instantly. And then I was able to just paste in all my things there. So the one downside to this is that when it adds them in alphabetical order instead of in the order they appear in your enum. So also by convention, enums are usually organized in alphabetical order up there to make them easy to read. So cat would be first, then monkey, then penguin. So I would do cat, monkey, penguin. I'm not going to knock you for this if this is something that you forget to do, but when you auto-generate things related to enums, you end up with them in alphabetical order anyway. So something to think about. Okay, well, with that finished, everything runs the way it used to. We can run this again, and we'll see it's does sick belly flip, knocks something over, invents society. All right. That's enums. Very useful if you need a distinct number of choices for some option, and you don't want to have to keep track of them with finals or integers. Very useful for that. And then later on, we'll look at how to give enums value. All right, let's do another. I'm going to close these and start another package. Let's call this one the food intro. This one's going to be food-based. I'm going to make a driver, as always. Check the box for the main method. And I'm going to start with a Okay, name some kind of food where when you eat it, you eat more than one at a time. So something that comes in bowl form in either chat. So not like apples or something, because normal people don't eat bowls of apples. Let's go with something that comes in large quantities, like the old Mitch Hedberg joke. Rice is when you want to eat 1,000 of something in one sitting. I butchered the joke, but something like that. Grapes. Go with grapes. So the name of the class would be grape, probably. Whenever we make object classes, we usually don't use the plural. We usually use the singular. So we'll have grape, and we'll have noodle. Grape and noodle. I'll work on noodle first. What are some of the properties that noodles might have? So we might want to know whether or not a noodle was eaten, and then we might want to be able to figure that out without getting rid of it. So public, this will be a boolean, is eaten, and of course by default it's false for all noodles. So we might want to know whether or not a noodle is eaten. Why wouldn't we want to keep one around if it's already eaten? Yeah, if it's not going to be eatable anymore, why would we still keep around its object reference? Because sometimes, even with object references in real life, if you think about it, you have to refer to an object that no longer exists. So something that was destroyed, or something that was in the past, but you still want to talk about some properties of it. Maybe you had a childhood bicycle and it was blue. When you talk about it, you're referring back to that instance of your childhood bicycle, regardless of whether or not it exists anymore. For you to be able to talk about it and discuss its color, you need to be able to address it. And likewise, sometimes you want to make objects where they have some kind of state that indicates that they're basically dead, like this. So once a noodle is eaten, it stops being functional in terms of whatever we're going to do with it. But we can still talk about fields that it might have had in the past, like maybe its color, its caloric density or something. Let's come up with a couple of those fields. We're going to go with is delicious. Noodles are obviously delicious and starchy. And then we're going to go with calories. Noodles are 5 calories. And let's write a couple of getters. Let's make calories private too. We would want people to be able to set the number of calories after the noodle is created. So we need get calories. Notice I'm avoiding using the auto generator for the getters and setters because I only need the getter here, and it's more straightforward for me anyway. So get is delicious. I think I spelled delicious wrong, but we're going to roll with it. That's a boolean instead. It's going to be get is eaten. Okay, does order matter for these? Well, technically no, but this is confusing, right? Because the variables appeared in that order up there, and now the getters appear in a different order. So it's a minor nitpick, and I'm never going to knock you for it or anything, but it's nice if your getters appear in the same order that the variables do, right? So it's nicer that way. I also like for your fields to all be together. Sometimes I like to group my fields by type like that, so the integers are separate from the booleans. It's up to you. Just come up with a convention that you like. Does noodle need a constructor? Do we need a constructor based on the specifications that I've set here? So in either chat, does it need a constructor? And then what happens when you don't specify one? I'm going to go over and do this for grape while you answer that. So does it need a constructor? What happens if you don't specify one? In the meantime, I'm working on grape. Grapes are not delicious, but they are a low-calorie snack. Low-calorie snack. All right, so let me answer the question. No, I don't think noodles needs a constructor. And the reason why is because there's no specific properties set. Every noodle that's made is generic and bland, and it doesn't actually need a customized constructor because there's no real difference between one noodle and another most of the time. What happens when you don't specify a constructor? Well, you get one. You just get this. By default, you get this, and it's not visible. So anytime you don't specify one, you just end up with that, and it's just not visible. It's in the background there. So if you don't specify a constructor, you just end up with a blank one. Remember, the default is not public. It's something like public that's the same for our purposes. So basically, you get that every time you don't specify. So if you don't specify a constructor, this is what you get. If you don't specify a constructor, you get one like this, invisibly in the background. And you might argue that we do need one to specify things. Of course, every noodle has unique locations and things like that, but we're not going into that much detail here, which brings me back to something I said the first day. When you're abstracting objects, the level of detail and the kind of stuff that you're interested in depends very much on your application. Obviously, I'm going to a place of culinariness here. I'm not talking about noodles from a physics point of view. I'm talking about them as food. That makes all the difference here. And then let's say there's a noodle alternative. Let's say I want to make another kind of noodle and I want to make it quickly. It's going to be basically the same but just with a different name. So you can copy whole classes like noodle, for example. I'm just going to hit Control-C for copy and Control-V for paste. And it's going to ask me what the new name I want is. So I'm going to go with wheat noodle. Again, I just clicked on the class name at the side. I hit Control-C for copy. I hit Control-V for paste. It's telling me I have a name conflict. Of course, you can't have two classes with the same name. And it's asked me what the new name I want is, and I said wheat noodle. Let's see what it made for me for wheat noodle. So you'll notice one key thing, in addition to changing the class name, it also intelligently found all the constructor occurrences and changed that to wheat noodle as well. So it was able to detect that I have a wheat noodle here instead of a noodle and change the constructor accordingly. All right, so I'm going to put that aside for now. Let's just work with noodle. And what dish involves multiple noodles? Let's make a class for a dish that involves multiple noodles. That's a dish that's a collection of noodles. Ramen. All right, we'll go with ramen. Uppercase, capital R, so ramen. Ramen takes an array of noodles. How many noodles in a bowl of ramen? Well, let's say it depends. Let's say we don't want to commit to a number at this point. So we designate an array of noodles, but we don't specify how big it is. Another thing I want to point out, in Java, there are two ways to make an array. There's that, and there's that, and they're the same. And usually I'll do that one, but sometimes I'll forget, and I'll put them at the end. These are both fine. Can't do both. Actually, maybe you can. I never tried. But these are the same thing. So you can put the square brackets wherever you want. That comes from basically just supporting the convention from other languages. Java lets you be a little flexible in how you want to declare an array. So let's say I don't want to commit to the size here. Let's say I want to commit to the size in the constructor. So public ramen, and then I'm going to ask for the size here. So you can instantiate arrays like this further down. So in this case, I would do it like that. Designate it there. Not noodle, noodle. All right, so you're able to create a field to hold the array and still commit its size in the constructor. This is something you're probably going to do a lot. This is probably something you're going to do on the homework too. You're going to maybe commit the array in the constructor. So you have to take an array of colors in one of your constructors. You're going to do that. So remember, you can have multiple constructors. Let's say you don't want to specify the size. Maybe there's a default constructor that just makes it, I don't know, 100 or something. So it just makes 100 noodles. So we don't want to have magic values like that. We don't want hundreds to just appear randomly in our program. So whenever you do something like that, you would probably have a final int instead that you would use. So this would be like a default noodle amount. And this avoids having to put a magic number 100 there. If you want to change it later on, rather than having to hunt for it in your code, you're going to just find it at the top and modify it. So try to avoid any kind of, we call them magic numbers, but basically just any kind of constants that appear in the body of your code. Whenever you have one of those, make it a final instead, so that it's easy to change. Unless it's something like you're doing mod 2 to find if something's odd or even. That's not a magic number. That's oddness or evenness is decided by 2. It's up to you to decide when something is sufficiently magical that it deserves a final like that. But this is one of those obvious examples where I picked 100 totally arbitrarily. I should be able to change it at the top. So it creates a bowl of ramen with the specified number of noodles, and then creates a bowl of ramen with the default number of noodles. And of course I can always direct people to it in case they're interested. Now, one of the annoying things is that when you read a hover over comment like that for an integer, it gives it to you like that. It doesn't actually tell you what the number is. Sometimes if it's a final, if it's a static final, then we can see what the number is. It'll show us here that it's 100, because remember, the statics get built separately. They get built when the program starts, and so it's able to determine what the number is going to be. So that's one advantage to making it static. In this case, it probably should be static because that's going to be the default amount of noodles for all bowls of ramen. It's not specific to one. Any bowl of ramen that we make is going to have that default noodle count. So it's fine to make it static in this case. It's something that's shared among all of them. Alright, so 2 constructors, depending on what kind of arguments you want to make. Of course, we can make more. We could even make one that takes an array of noodles you already have. So let's say this one takes this one makes a bowl of ramen out of noodles you provide. Okay, so you can simply accept the array like that. Nothing fancy there. So in these two, I'm missing something, right? We talked about this briefly with the doodads. I'm missing something. I've made the array, and that's the placeholder for the noodles, but I haven't instantiated the noodles themselves yet. So right now, all of the spots in this noodle array, even after these 2 lines here, all those spots are null. Alright, so I'm going to make another method. I'm going to call this refill bowl. And this is going to populate that array with noodles. So in either chat, how do I fill the entire noodles array with noodles? How do I actually populate it with objects? You don't have to be syntactically correct, just roughly. How do I populate it with objects? So populates the ramen bowl with fresh noodles. Give you a hint, we're going to have some new in there. We're going to have some noodle in there. There's going to be a for loop. Not in this particular order. Something you're probably going to do a bit on the homework too, looping through all the elements that you've got. Close. That's an array declaration. So that's going to declare our array to be of a certain size. But remember, when we made the array, it's still full of nulls. It's not full of noodles yet. It's full of nulls. It's full of references that could be noodles if we had made them, but they are not yet. So just like when you make a new string array, there's nothing in it originally. They're just null. So we need someone said a while loop. Usually when we're iterating through an array of objects, it's going to be a for loop. Let's look at how we do it again. So we're looking for all of the spots in the noodles array, so from I0 to noodles.length. So for all of the spots in the noodles array, because that's what they are, they're not noodles yet, they're just spots that can be noodles. We're going to instantiate a noodle in each spot. Okay, so this is what actually instantiates the 1,000 or 100 or whatever noodles that are in the ramen. This is what actually creates them for use. Now we can call on them and call on their calories and what have you. Before that, if we tried to call on them, we would get a null exception. Okay, we want to do this anytime that we create a new bowl of ramen using either the size or the default amount. We're going to do that regardless. If we already get an existing bowl of noodles, then we're not going to do that. Okay, let's write a couple utilities. Let's say you want to take byte, public int byte, and this is going to return how many calories you just got in that byte of noodles. Let's see. Let's say eats up to 10 noodles in a single byte and returns the number of calories you ate. Number of calories you ate. So I have int calories that I'm going to use to take the sum, and I'll return it at the end. So I said 10, so let's go with I0, I is less than 10. What should I do here instead of using 10 in either chat? What should I do instead of using 10 like this, which is a bad idea? I should create a final variable. So let's do that. Private static final int. I'll call it noodles per byte. And that's going to be 10 instead. And then rather than saying 10 up here, I can say link, and then link to the noodles per byte, which you can change down the road. So now, if you want to know how many you're eating per byte, well, it's going to be that many. And if this is consistent for all bowls, then it's fine to make it static too. Okay, so what am I doing here? Well, I'm 10 times picking a random noodle out of the bowl. So this is how you pick a random index. Pick a random index out of the noodle array. I just made this in one line rather than in multiple like you might be used to. You might be used to doing something like that and then putting this there. But I like to try to shorten these into a line whenever it's short enough that it doesn't kind of wrap around. So I'm picking a random index out of here. I did math.random, and I multiplied it by the length of the noodles array. and then I cast it as an integer. That gives me a random index between 0 and the length of the noodles array. And this is safe from going out of bounds because math.random can never evaluate to 1. It's always going to be less than 1.0. It can be 0.999999, but it'll always end up rounding down, which is very convenient for picking random arrays like this. All right, so I want to eat the noodle. So I want to check if it's eaten. All right, if it's not eaten, I'm going to eat it. Okay, so how do I do that? Well, I haven't specified that yet. So I got to go back and I got to make a method. Let's go with public void. I'm just going to call it eat. And then it sets as eaten to true. So just like with the wire, I had an isCut, I had a cut method. This one's got an eat method. It sets that as eaten to true. All right, so back to here. So I'm going to eat it. And I'm going to add its calories to my sum that I'm tracking here so far. Like that. Okay, now I could do something a little different. I could have eat return how many calories you get. That's one alternative. And that allows me to do this in one line. So this would be sets the noodle to eaten and returns how many calories you just ate. If I do it that way, then I don't have to do this line here. I can do that instead. Do that instead. Someone asked if I need to do this dot is eaten. Sure. It's still in cyan, even without the this. So remember, if there's no ambiguity, if there's no local variable with the same name, it's clever enough to infer the this. But technically the this is always there, yes. It's just in the background. So all these light blue variables, all the ones that refer back to these fields at the top, actually have that hidden this in front of them. And you can omit it if there's no ambiguity, but it's always there. So I could do that. Or I could go one step further even and also do the check for whether or not the noodle's eaten here. So if this noodle is uneaten, sets the noodle to eaten, returns so many calories. Otherwise, there's nothing, and returns 0. So we could do if is eaten here, rather than doing it in the bowl class. So it's up to you whether or not this property of noodles, the ability to eat them, belongs to the object or it belongs to methods calling on the object. It's up to you. And this will be a problem that you often run into. Do I perform the check for is eaten here, or do I perform it on the object? If I perform it on the object, then this becomes much shorter. All I have to do is that. It'll check for me. If it's eatable, it'll add the calories accordingly. If it's not eatable, it'll just add 0. So that's all taken care of for me. But of course now it's longer here. So you're always able to move things around like that. Okay, so that's eat some random amount of noodles, returns how many calories you just ate. Well, let's give it a shot in our last couple of minutes here. I'm going to go into the driver. I'm going to make a bowl of ramen. Remember, I have a few different ways to do it. I could just specify the number of noodles I want, or I could use the default. I'm going to specify the number I want. Int calories eaten total. It's going to be 0 to start, and then I'm just going to keep eating out of it and then printing it out. So plus equals bowl dot byte. And then I'll print it out. And then I'll just do this a few times. I could put this in a for loop, but we've only got a minute left, so probably easier to do this. Oops, don't want that line. I'll just take a few bytes and see how it goes. Let me make this quantity smaller so that we have a better impact. Let's do 150 noodles. Okay, so the first time we took a bite, we got 50 calories. Then obviously we got another 50 because we're up to 100. And then we got 5 less because we only got 145 that time. We only got 45, and we got 40. So some of those indexes ended up having noodles that were already eaten. We didn't have to perform a null check because we have that ability to set the noodle to dead, to eaten state, without getting rid of it. So this is another advantage to doing something like this, where you have a state that represents where an object is dead. You can have an array of those objects where you can make some guarantees that none of them are going to be null at any point, because you don't get rid of them. All right, we'll continue with this next time. Some of this material should be helpful for your homework, and then if you're still confused, we'll cover another couple things that might be helpful next time. Let me know if you're having trouble with that first homework. It's definitely the first hard one. I might extend it to Tuesday if enough people have trouble. So post any kind of questions you have there on Discord. And if there's not too many questions, it'll probably be due Thursday still. All right, that's it for today. See you guys next time.